Recording in progress.
So, hello everyone, and welcome to this session on GATE problem solving sessions for physics. So, can someone tell me if they can hear me and if they can see my screen?
Yes, ma'am.
Okay, fine, great. So, just as a reminder, so these are GATE problem solving sessions for physics. These sessions are held every Saturday, 1:30 p.m. to 2:30 p.m. 1 hour sessions every Saturday we have, and it is supposed to be running for 12 weeks. And this is our fourth meeting over here. So we have 8 more sessions remaining, and I would put up all the links over here. So we have a few links which you can follow for notes and for these videos. So these meetings are always recorded, and they are put up on YouTube as a live streaming. So you can watch the video later on YouTube as well. I'll just put up the link of the YouTube channel for those of you who don't have it. So here is the link to the YouTube channel. You can go ahead and subscribe to the channel, and then you will come to know about every such problem solving sessions that we have. Apart from this, we have a Google Drive link, a Google Drive folder where we upload all these lecture notes of every week. So all these problem solving sessions, all these problems and the solutions are available on that Google Drive link. I will put up the link in just a minute. So you can bookmark the Google Drive link and save it so that you can access it easily anytime you want it. So I have put the link of the Google Drive folder in the chat box as well. Apart from this, we also have a Discord server which you can join and chat with your friends and colleagues. And if you have some questions, you can put up the queries in the Discord server as well. So I'll just give you the link to the Discord server over here again in the chat box. So you can go ahead and join the Discord server. I'm just typing the Discord server link in the chat box. So that's the link to the Discord server. So these are the 3 main links important for our course. First one is the YouTube channel. Next is the Google Drive link, and finally the Discord server. So do we have some new people joining us over here in this session who have not attended the previous sessions? If yes, you could just unmute and say yes, or type in the chat box yes, so I will get an idea if we have some new people. If not, then we proceed. Okay, Rituraj, you are joining for the first time.
Yes, sure.
Okay, so Rituraj, these are the 3 important links pertaining to this course. So the YouTube channel, Google Drive link, and the Discord server. So you can save all of this somewhere so that you can access them easily. So Discord server is to join. You can join and pose your questions over there. Google Drive, you can bookmark where these notes will be uploaded, and YouTube channel is where all these videos are available. So even if you miss some sessions, you can even go ahead and watch the previous week's sessions. So you can go ahead and open that YouTube link and subscribe to it. So these are the 3 links for important for you, Rituraj. And we will be focusing on 4 topics. So general aptitude, mathematical physics, electromagnetic theory, and quantum mechanics. So every session we take up few questions from 2 of these topics. One is general aptitude, and another topic is any one of either mathematical physics, electromagnetic theory, or quantum mechanics. So last week we did mathematical physics. This week we will be looking at some questions from electromagnetic theory. So first few questions on general aptitude, then few questions from electromagnetic theory. So that's the plan. So every week we solve roughly 8 to 10 questions, and this is how we proceed. So again, as I mentioned, so we will start with general aptitude over here, and then we will proceed to electromagnetic theory for today. So here is the first question in general aptitude. By the way, in general aptitude, there are a lot of these English-based questions. So you need to have a decent understanding about English language, the English vocabulary, the English grammar, all these things. You should have a decent understanding, and you should be able to do some logical reasoning and comprehension as well. So this first question over here is like a comprehension question. So if you remember in your school days, you might be having something called an unseen passage, or you would have some comprehension questions based on that unseen passage. So this is like a short passage over here. So it goes like, modern warfare has changed from large scale clashes of armies to suppression of civilian populations. Chemical agents that do their work silently appear to be suited to such warfare, and regretfully, there exist people in military establishments who think that chemical agents are useful tools for their cause. Which of the following statements best sums up the meaning of the above passage? So, not that we should encourage warfare, in fact, we should encourage peace. So, I do not quite like this question, but these are questions from previous year's GATE physics problems. So we will be actually, Rituraj, you are new over here, so we are focusing on previous year's GATE problems from 2010 to 2021. So we have these 10 to 12 years question papers, and we are looking at these questions from those previous year GATE physics problems. So not that I like this question, because I am a very peace loving person, but nevertheless we have this question over here, so we need to answer it. Option A says modern warfare has resulted in civil strife. So indeed a true statement, but it is not what we can conclude from this above passage. So option number A is not correct. Chemical agents are useful in modern warfare. So this is also not exactly the full gist of the above passage that we have. Use of chemical agents in warfare would be undesirable. Again, it's a true statement. I mean, I would not want anyone to indulge in warfare, so whatsoever. So, but then again, this is not the conclusion from the passage that we have. So, option D is the correct option. That's the conclusion. The conclusion is, people in military establishments like to use chemical agents in war. So, that's the correct conclusion from this passage. So, this passage is about warfare, and that people in military establishments think that chemical agents are quite useful. So this is a simple comprehension passages. So you would get some such comprehension passages in your general aptitude section, and you should be prepared to answer it. I would expect that all of you score full marks in general aptitude. That's one section which you should aim at getting full marks, and then proceed to the next sections. So our next question is based on vocabulary. So it's like a fill in the blanks type of question. So it says, choose the most appropriate word from the options given below to complete the following sentence. If you are trying to make a strong impression on your audience, you cannot do so by being understated, tentative, or dash. And we have a bunch of options over here. We need to select the correct word, and the correct option in this case, could someone just type in the chat box? You have 30 seconds to give the answer to this question. People just type in the chat box. What do you think would be the correct answer to this? Just write A, B, C, D, whatever you think is the correct answer in the chat box. Okay, Rituraj has written. If other people can also write in the chat box and send the message to me. Okay, so yeah, some people have responded as a direct message. You could write it in the general, no need to send direct message to me. You could send it to everyone. There is nothing to hide over here, nothing secret over here. we are all sharing knowledge with everyone. Okay, so great. I see most of you have got it right. So the correct option is restrained. So again, as I have always been doing, my favorite dictionary to check up the definition of words is Oxford Advanced Learners Dictionary. It is pretty much the standard, the most standard I feel. So it's like one of my favorite dictionaries. So Oxford definition of restrained. So restrained over here is being used as an adjective. It is not in the past tense form of the verb restrain. This word over here is being used as an adjective. So the definition of restrained as an adjective is, according to Oxford, showing calm control rather than emotion. And another dictionary, which is also pretty good and you could look up, is Cambridge Dictionary. So either Oxford's dictionary or Cambridge Dictionary, you could follow either one of them. Both of these dictionaries are pretty good and pretty much standard, and they also have mobile phone app. So if you want, you could either access their online dictionary or you could get their mobile phone app. So yeah, I quite like the app because like when you are traveling and when you are not having, let's say, proper access to logging into some website, then you can use the app version. So Cambridge also defines it similar way, acting in a calm and controlled way. And some example sentence would be, I was expecting him to be furious, but he was very restrained. So furious would be like the opposite of restrained. So restrained is being very calm and controlled and composed. So again, this was like a vocabulary based question. Not that I fully agree with this. I would feel that one should rather be more calm and controlled rather than showing a lot of emotion. That is my feeling. But yeah, these people think that in order to make an impression, you should not be controlled or restrained or tentative. So anyway, the other options over here are hyperbolic, argumentative, and indifferent. And these are definitely not the correct options over here. Hyperbolic is like completely opposite of restraint. It's like showing too much of uh, emotion, being too much exaggerated. Argumentative, as the word suggests, is trying to be like trying to argue in a very not so calm tone, trying to put forth your viewpoints in a very sort of loud manner. So that is argumentative, just arguing for the sake of arguing, not trying to make much sense. And indifferent is like, I do not care. That kind of attitude is indifferent. So none of these other three options are correct, and the correct option is indeed restrained. Next, we have some simple question. So this question says, if log p is equal to half of log q is equal to 1/3 of log r, then which of the following options is true? And we have a bunch of relation between p, q, and r. So we need to figure out which one of them is true. So let us solve this question. So let us start. So log p is given to be half of log q, which is 1/3 of log r, which is equal to, let us say, some constant, say lambda. Then from here we get what? P is nothing but e to the power lambda. Q is nothing but e to the power 2 lambda. and r is equal to e to the power 3 lambda. And so let us just find q squared because it's coming up in quite a few options. We have q squared here, q squared here, and q squared here. So let us see what q squared is. Q squared would be e to the power 4 lambda. So, and let us see what p times r is. P times r is e to the power lambda, that is p, e to the power 3 lambda, that's r, which is e to the power 4 lambda. So from here, we can clearly see that q squared is equal to p times r. So this is the correct option. So you can see that the other options are incorrect. For example, if we look at option A, so p squared would be what? It would be e to the power 2 lambda. Q cube would be e to the power 6 lambda, and r squared would again be e to the power 6 lambda. So you can clearly see that from here we see p squared, sorry, let us find out this q cubed, r squared, this is e to the power 12 lambda, and this is definitely not equal to p squared. So this option is incorrect. Option A is incorrect. Similarly, you can test for option C and option D, and you would realize that they are incorrect options. So the only correct option over here is option B. So let's proceed further. Another question on in the general aptitude section itself. It goes like, so by the way, if any one of you have any question, you could stop me in between and we can discuss whatever doubt or query that you have. Hopefully everyone has understood everything up until now. So we will proceed further. And if you want, you could even type your query in the chat box. I will check it and I will try to answer your query. So this is the fourth question. It goes like, a transporter receives the same number of orders each day. Currently, he has some pending orders or backlog to be shipped. If he uses 7 trucks, then at the end of the 4th day, he can clear all the orders. Alternatively, if he uses only 3 trucks, then all the orders are cleared at the end of the 10th day. What is the minimum number of trucks required so that there will be no pending orders at the end of the 5th day? So let us try and solve this question. So let us say X is the number of pending orders. And let T be the number, sorry, let the T be the capacity of a truck. Capacity of a truck means number of orders, sorry, not numbers, number of orders a truck can clear per day. So the number of items or orders a truck can ship in a single day, that we are taking as T. And finally, let N be the total number of orders received in a single day. So again, this is the thing. These are the variables that we are defining. And let us now try and form the equations between these 3 variables based on the facts that we are given. So the first fact that we are given is that using 7 trucks, so using 7 trucks, he can clear all the orders at the end of the 4th day. So this is the first information that we have, and we can form the equation corresponding to this. So we have 7 trucks and 4 days So this is the first equation that we can form based on this equation, or based on this information given. So the information given is that 7 trucks can clear the order in 4 days. So we have 7 trucks. Uh, each truck has a capacity to carry T number of orders per day, and we are taking 4 days. So that's why it is 70 into 4 over here. Then on the right hand side, we have what we have? We have total number of orders, that is n, and n is total number of orders in 1 day. So total number of orders in 4 days would be 4 times n, and plus we did have some pending orders remaining. So we were given that he has some the transporter has some pending order remaining. So this is the first equation that we form based on this fact that we are given. So 7t into 4 is equal to 4n plus x. Could someone tell me what the next equation would be? You can type in the chat box what the next equation would be based on the fact that we are given. We are given the next fact that we have, if we have 3 trucks, then we can clear it by the end of the 4th day. So people just write down the equation corresponding to this fact. So I have written down the equation corresponding to the first information that we are given. So people, if people can type in the chat box what you think the equation corresponding to this second information that we're given would be. So just write down in the chat box. I will write it for you because I will solve this question. So just write down whatever you think is going to be the equation. Okay, so I see that some people are writing. Yeah, most of you are getting it right. So, okay. So for those of you who did not get it right, I will explain it over here. So next equation we have, as most of you have written correctly, 3t into 10 is equal to 10n plus x. Now, why we have this? Because we are using 3 trucks. So 3 trucks, that's why 3t over here, each truck having capacity of t. And then how many days? 10 days. That's why it's into 10 over here, because each truck has capacity t for per day, and you are having 10 days. So 3t into 10, 3 being the number of trucks. Then on the right hand side, since we have 10 days and number of orders per day is n, so that would be 10n, and we already had x number of pending orders. So that is still there. We need to clear the pending orders. So that is x over there. So these are the 2 equations that we have. So from the first equation, we can get x is equal to 28t minus 4n. That's x from the first equation. And from the second equation, x will come out as 30t minus 10n. Now, equating these two, we get what? We get 28t minus 4n is equal to 30t minus 10n, which implies we have 6n is equal to 2t, which implies t is equal to 3n. So we find t in terms of n, and then we can plug it back into one of the equations. We know x is equal to 30t minus 10n. So, and t in terms of n is from here. So that is 30 into 3n minus 10n, which is nothing but 80n. So we find t and x both in terms of n. So therefore we have the number of pending orders. That was, remember, we defined x. So x, which is equal to 80n. And in now we are supposed to find out in 5 days how many trucks are needed. So in 5 days, 5n more orders we will get, because each day we get n orders. So in 5 days, 5n more orders will be received apart from the x pending orders. So that would make us that we have the pending orders, that is x plus the new orders per day, that is 5n. So this is nothing but 80n, because x is 80n, plus 5n, which is 85n. So 85n orders have to be cleared. So the number of trucks that we would need to clear 85n orders, this would be equal to 85n, that's the number of orders, divided by t into 5, because you have to clear in 5 days, and t is the capacity of a single truck. So this is 85n, and t we have found in terms of n, that is 3n into 5, which is equal to 85 divided by 15. N cancels from numerator denominator. 85 divided by 50, so 15, sorry, so this is 5. Let us simplify. 3 5, so this is 17 by 3. So this is not an integer, but the closest integer to this would be not closest, but the minimum possible integer that minimum. So we need to find integer. We can't have a half a truck. We need to have 1 truck, 2 truck, 3 trucks, 4 trucks, like this. We can't be having like 1.5 trucks. That doesn't make any sense. So 17 by 3 would be a decimal, which would be larger than 5. It would be 5 point something, and it would be less than 6. So the number of trucks that we need to have at least would be 6, because if we have just 5 trucks, we will not be able to clear the orders, because we need 17 by 3 trucks, and that is greater than 5. That's a decimal which is greater than 5. It is 5 point something. So in order to be able to clear the orders in 5 days, we need 6 trucks. Of course, if we have more number of trucks, we can clear it earlier, but for clearing in 5 days, we definitely need at least 6 trucks. So we need 6 trucks for clearing the orders in 5 days. So the correct option is option number C. So moving on, now we will look at some questions from electromagnetic theory. So this was for general aptitude. Now we will focus on electromagnetic theory. So we have the first question in electromagnetic theory. Two magnetic dipoles of magnitude m each are placed in a plane as shown in the figure. So we have this figure over here which shows two dipoles being placed. Then we need to find out the energy of interaction, and we have these 4 options. We need to select the correct option for energy of interaction. So we see that these 2 dipoles are placed over here at location 1 and location 2, and we are given the angle that they make, and the line joining the dipoles kept at location 1 and 2, the distance of that is given as d. So we know that the formula for energy between 2 dipoles, the energy between any 2 dipoles is given as follows: mu naught over 4 pi r cube m1 dot m2 minus 3 m1 dot r cap times m2 dot r cap. So this is the energy that is there. This is the energy of interaction between the 2 dipoles. Now we clearly see that m1, that is dipole over here, and this dipole over here, they are perpendicular. That is m1 is perpendicular to m2 in our case. That means m1 dot m2 term is equal to 0. And for our case, r is nothing but d. So what we have is u is mu naught over 4 pi d cubed, because r is d. m1 dot m2 is 0 minus 3 m1 dot r cap. So this is r cap. So this direction right here. So this direction is the r cap unit vector direction, which joins m1 and m2 along that line joining m1 and m2. So that is our r cap vector. And we clearly see that the angle between m1 and r cap is 45 degrees. So m1 dot r cap would be m cosine 45 degrees. And similarly, m2 and r cap also make an angle of 45 degrees. We see that this angle right here, or we are also given, is 45 degrees. So angle between m2 and r cap would also be 45 degrees. So we have again m cosine 45 degrees. And cosine 45 degrees is nothing but 1 over root 2. Sorry, not 1 over 2, 1 over root 2. So this gives us mu naught by 4 pi d cubed minus 3m squared divided by 2. 1 over root 2 from here, 1 over root 2 from here. So minus 3m squared by 2. So the correct option would be, so this 2 and this 4 would combine to give you 8. So minus 3 mu naught m squared over 8 pi d cube. That's the correct answer. So the correct option is option number D, minus 3 mu naught m squared over 8 pi d cube. So this was a very simple question of a simple configuration of two dipoles, and we had to find out the energy. So energy of interaction is nothing but the potential energy of the configuration. So sometimes people might use potential energy of the configuration or energy of interaction. So different words being used, different phrases for things which mean exactly the same. So you should not get confused by that. So here we have another question. It says two charges, Q and 2Q, are placed along the x-axis in front of a grounded infinite conducting plane as shown in the figure. So we have this figure over here showing the configuration of charges. They are located at a distance of 0.5 meter and 1.5 meter respectively from the plane. The force acting on the charge Q is, we need to find out the force acting on the charge Q. So this is the charge Q placed over here. And this Q is 0.5 meters from the infinite grounded plane. So this is the infinite plane which is grounded. And then 2Q is placed 1.5 meters from the infinite grounded plane. And this horizontal direction right here is the x-axis that we have. And we need to find out the force on the charge Q. Now, this question we can solve by the method of image charges. So, using the method of image charges, we can redraw this configuration as an equivalent configuration. So the method of image charges says that if you have the infinite plane, so this is the location of, let us call this as the origin. So this is our origin over here, and this is the x-axis. So if we have the origin over here, then we have Q. This is the origin. We have Q placed at 0.5 meters. We have 2Q placed somewhere over here at 1.5 meters. And this is the location of our infinite grounded conducting plane. So the method of image charges says that if you have the infinite grounded conducting plane, you simply reflect your charge configuration about the axis, about the plane. So the plane is like the mirror plane that you have, and you simply reflect your charge configuration. So if we have Q over here, then we would have an image charge corresponding to Q as minus Q, exactly at the same distance but behind the conducting plane. And then we would have minus 2Q as the image charge of Q. So let me use some different colors to make sure which one is image charge of which configuration. So this is for Q, then we have for 2Q. So this minus Q is image charge for Q, minus 2Q is the image charge of 2Q. So either we can work with this configuration which is given as the infinite conducting plane and the charge configuration given, or we can use this equivalent figure. Equivalent. So this configuration can be written as an equivalent diagram over here only for the case x greater than 0. So only in this region. So only in the region, in the positive x region. In the negative x region, you cannot use this charge configuration that we have created by the method of image charges to find out stuff in the x less than 0 domain. So only in the positive x domain, we can replace this infinite grounded conducting plane by this charge configuration to solve the basically force or electric field or potential in the domain where x is greater than 0. So in this domain. And why this image charge configuration works? Well, because this image charge configuration that we have along with this charge configuration that we have on the right hand side, so the right hand side and left hand side charge configurations give us the potential V equal to 0 along the plane situated at the origin and perpendicular to the x-axis. So because of this grounding, we know that infinite grounded conducting plane means that potential of the plane is 0. And using this kind of minus 2q minus q plus 2q kind of charge configuration, you are able to replicate that situation of having potential equal to 0 along that plane. So that's why we can replace this conducting plane by this charge configuration to simplify our basically simplify our problem. But it only works in the positive x direction. You cannot use this configuration to find out stuff in the negative x direction. So let us now find out the force. So force, so this is, this is V equal to 0. So force acting on this Q charge would be due to 2Q right here, 2Q on this side. So this is force due to 2Q. Since it's both these charges are of the same sign, so that's the direction of the force, it will repel. Then we have force due to this minus Q. So we have this force due to minus Q, and this minus Q will try to attract plus Q because these are opposite signs. So again, we have this direction, that is negative x direction, and then we have force due to minus 2Q. Again, so all these three forces act in the negative x direction over here. And we can simply use the Coulomb's law to write down the force. By the way, these distances are, let me write down 0.5 meters. This is also 0.5 meters. This right here is 1.5 meters. And this is also 1.5 meters. So let us write down the force. So force acting on Q is force due to 2Q plus force due to minus Q plus force due to minus 2Q, and all of this is acting in the negative x direction. So resultant is also in negative x direction. And by Coulomb's law, we have the force, which is Q over 4 pi epsilon naught times force due to 2Q would be 2Q divided by R squared. So R is the distance between Q and 2Q, and that would be 1.5 meters minus 0.5 meters. So that is 1 meter. So R squared, that is 1 squared. Then due to minus Q. So that would be Q divided by, now the distance is again 0.5 meters plus 0.5 meters, that is 1 squared. Notice that I have not put the minus sign because that takes care of the direction. So once I know which direction, then I can just use the magnitude. So I know that all of these are acting in the negative x direction. So that I've already specified over here. So I'm just writing the magnitude over here. And then due to minus 2q, that is 2q divided by, so the distance is 1.5 meters plus 0.5 meters, that is 2 squared. So we can simplify q over 4 pi epsilon naught. Again, notice that I did not write minus 2q because minus sign takes care of the direction of the force, which we have already specified as negative x direction. So q over 4 pi epsilon naught times 2q plus q plus q by 2. And that is nothing but q over 4 pi epsilon naught 7q over 2. So 7q squared over 4 pi epsilon naught into 2. So the correct option is option number A. So that's the correct answer. Next, we have a very simple question. It says a magnetic dipole of dipole moment M is placed in a non-uniform magnetic field. If the position vector of the dipole is R, then the torque acting on the dipole about the origin is, we have a bunch of options, and even so it's just a simple formula based question. You should be aware of this, that option C is the correct, because we have torque is given as M cross B. So you were given this additional extra information of the location of the dipole being R. That is fine. So that's like extra information. So they just gave it to you to try and confuse you. And then you have this bunch of options with R involved. So that was just there to confuse you. And you can even see that option A is dimensionally incorrect, because it is the dimensions. If you look at the dimensions of this would be a dimension of the distance times the dimension of the magnetic dipole times the dimension of the magnetic field. But we know that torque is M cross B. So dimensionally, if you try to find out the dimensions of this, you would have the extra dimension of R. So dimensionally also, this expression is incorrect. So sometimes when you are not able to solve the question, this was very simple, but sometimes when you are not able to solve the question properly, you can use this dimensional analysis to rule out the incorrect options. So for example, if I did not know the correct option, even then I could just rule out option number A, because I know that dimensionally these dimensions do not match up to the dimensions of torque. So sometimes dimensional analysis can prove to be a useful tool in trying to eliminate or reduce your number of options that you have, and then you can try and figure out which one would be the correct answer. So yeah, this was pretty much simple. Then we have another question. This is pertaining to magnetic field and vector potential. So the question says, which of the following expressions for a vector potential A does not represent a uniform magnetic field of magnitude B0 along the Z direction? So what we know, the relation between magnetic field and vector potential is given as follows. B is equal to del cross A. Which, and for our case, we are given that B is a uniform magnetic field in the Z direction. So we have B is nothing but B0 in the Z direction, which is, if we write in the component form, it is like so. So B0 K cap or B0 0 0 1 vector. So we have this expression as the relation between magnetic field and vector potential. So let us try each of these options. So option A, we can find out del cross A, and del cross A, how we find it, is the determinant of the following matrix. So this is our del cross A, and we can find out this determinant expanding along the first column, sorry, the first row. So we expand along this first row. So this is for I cap, then we have minus j cap, then k cap, so we can clearly see that all the other terms are 0, only the k cap term exists. So this is k cap b naught, which indeed is the b that we are given. So this is the option which says that it represents b. So but we need to find out something which does not represent. So you need to be careful, you need to read the question. Sometimes what happens is we do not read this word not over here. So that is very much important. So sometimes in true false these kind of questions we end up answering for what is true as opposed to what is false, which might be the question. So over here the question asks which of it does not represent, so that not word is very important. So A does represent the magnetic field that we are given, so option A is incorrect in that sense. So let us look at option B. So option B, del cross A. Again, we'll write del cross A. It's I cap, J cap, K cap, del by del X, del by del Y, del by del Z, and B is what? Minus B naught Y, 0, 0. So let us find out. I cap component, then the J cap component, then we have the K cap component. And again you see that I cap component 0, J cap component 0, only K cap component survives, which is K cap B naught, because this negative and negative cancels. So you indeed get back your B. So that's that. And then you have option C. Let us try out the option C. So we have del cross A, then this vector field is like so. That's the vector field for option, sorry, vector potential for the option C. And let us try and find out. So now the K cap component, that's the K cap component. And you see that each of these components are 0. So this is the 0 vector, which is clearly not equal to our B. So the correct option is C, because C is a vector potential which does not give us the correct B that we want. And just for checking purpose, we can check for option D as well. This is just to check whether D indeed gives us the B that we want. So ICAP component, then we have the JCAP component, and finally the KCAP component. So ICAP component 0, JCAP 0, and we have this B naught by 2 plus B naught by 2, that is B naught KCAP, which is the B. So the correct option is C over here. So that's all for today, and hopefully you were able to understand all of these questions. In the next week, we will look at some questions from quantum mechanics. So we will do this cycle. So we will take up some questions from general aptitude and then some questions from quantum mechanics. Then the week after that, we will go back to mathematical physics, then again electromagnetic theory, and then again quantum mechanics. So this the 4 sessions are complete. We have 8 more remaining sessions. So that's all for today. And I see that there is some question in the chat box. So Rituraj wants to ask the question. I may not be able to answer that question today because I'm running short on time. I do have another class right after this session. So, but Rituraj, you are trying to ask how to do using tensor, using Levi-Civita symbols. Could you just unmute and ask the question as to what you want to ask in this over here, Rituraj?
Since the options are it is asked that not satisfy the relation, so we have to check every time.
Yeah.
But if we use a with a symbol, we can do faster. That's why I am asking you.
Okay. So yeah, so Levi-Civita symbols are used to denote any kind of cross product per se, and you can use that as well if you feel like to denote this curl over here in terms of that. So you want to understand how to use Levi-Civita symbols. So maybe what we can do is in the next session, I could instead of just solving the problems, I could start with some theory, some basic theory about the Levi-Civita symbol and how to use that in this situation. So yeah, whatever works for you, simplest, that is the method that you use. So next class, maybe we will discuss how to work with Levi-Civita symbols and do such vector calculus with Levi-Civita symbols. So yeah, any other query? Yeah, by the way, but you would indeed have to kind of so all these kind of questions which are there, stuff which says that you need to find out the correct option, more often than not, you would have to kind of check through the options. Like there is uh, that turns out to be some like the faster way rather than trying to come up with some kind of expression and trying to solve the problem. So more often than not, you would notice that you encounter these kind of questions which require you to do this option checking stuff, like go A B C D and check the stuff. So that thing is there, whether you like it or not, you have to deal with it. So any other question? We will definitely look at the Levi-Civita symbol in the next class.
Thank you, ma'am.
Yeah, okay, fine. Okay, so if there is no other query, then that's all for today's session. And so I have given all the links that are important, all the links that you could save for your reference, and you could go ahead and check out those links. And today's session is over. So if you do not have any question, you could leave the session.
Recording stopped.